Imagine a world where three-dimensional images float in midair. No screens, no glasses, just pure light forming solid objects before your eyes. Sounds like science fiction, right? This is the captivating promise of holograms. And believe it or not, we are closer than ever to making this a reality. For decades, holograms have captivated our imaginations. From Princess Leia's plea for help in Star Wars, to futuristic displays in countless sci-fi films, the allure of true 3D projection is undeniable. But holograms aren't just a thing of the future. They're rapidly becoming part of our present. The journey from science fiction to science fact is paved with innovation and driven by our desire to interact with information in more intuitive and immersive ways. Today, scientists and engineers are pushing the boundaries of what's possible, bringing us closer to a future where holograms are as commonplace as smartphones are today. The future is bright, the future is holographic. Before we dive into the exciting world of holographic technology, let's clarify what we mean by hologram. We often hear the term used loosely to describe various 3D visual effects. But true holography is different. It's not about trickery or illusion. Take, for example, the famous Pepper's ghost illusion. This technique uses strategically placed glass or foil to reflect images, creating the illusion of a ghost-like apparition. While impressive, this is not a hologram. It's a clever manipulation of light and reflection. True holograms, on the other hand, work by recording and reconstructing the entire wavefront of light. This means capturing not just the intensity of light like a photograph, but also its direction and phase. This complex process allows holograms to recreate the depth and parallax of real objects, making them appear genuinely three-dimensional. So, while other technologies might mimic the look of a hologram, they lack the fundamental science behind true holographic projection. To understand the magic of holography, we need to delve into the fascinating world of light. Light, you see, travels in waves. Just like ripples on a pond, these waves have peaks and troughs. Holography exploits a property of light waves called interference. When two waves meet, they can either amplify or cancel each other out. This interaction creates a pattern. Creating a hologram involves recording this interference pattern onto a photosensitive material. This recording is done using a laser beam split into two paths. One beam illuminates the object, and the reflected light interferes with the second beam, creating the holographic recording. Later, when you shine a laser, or sometimes ordinary light, onto the recording, the interference pattern diffracts the light, reconstructing the original wavefront of the object, and making it appear as a three-dimensional image. It's like capturing a three-dimensional snapshot of light itself. While the concept of holography might sound like something out of a science fiction novel, it is rapidly becoming a part of our reality. The idea of projecting three-dimensional images that can be viewed without special glasses has fascinated scientists and technologists for decades. The truth is that holographic technology is already making its way into our daily lives in ways we might not even realize. From the entertainment industry to practical applications in security and data storage, holography is slowly but surely becoming ubiquitous. Take, for instance, those shimmering security stickers you find on credit cards or banknotes. These small, often overlooked features are actually simple examples of holograms. They are created using sophisticated micro-patterns that diffract light to produce a three-dimensional effect, making them difficult to replicate and thus enhancing security. These micro-patterns are meticulously designed to interact with light in specific ways, creating the illusion of depth and movement. This not only makes them visually striking but also serves a practical purpose by making counterfeiting much more challenging. But holograms are capable of much more than just security features. Imagine a world where you can interact with three-dimensional images projected into the air, without the need for any special glasses or equipment. This is not just a dream, it's a reality that researchers and companies are actively working on. Researchers and companies are developing advanced holographic displays that project three-dimensional images visible without the need for special glasses. These displays use lasers or precisely controlled arrays of LEDs to recreate the wavefront of light, bringing holograms to life in a way that feels almost magical. These displays use lasers or precisely controlled arrays of LEDs to recreate the wavefront of light, bringing holograms to life. The technology behind this is incredibly complex, involving the manipulation of light at a microscopic level to create images that appear to float in midair. And then there's the realm of holographic data storage. Imagine storing massive amounts of data not on spinning disks or silicon chips, but within the very structure of a crystal or polymer. This is the promise of holographic storage, offering unparalleled data density and longevity. Holographic data storage works by using light to record information in three dimensions, allowing for much higher data densities than traditional storage methods. This could revolutionize the way we store and access information, making it faster and more efficient. This is the promise of holographic storage, offering unparalleled data density and longevity. The potential applications are vast, from archiving massive amounts of data to creating more efficient and faster data retrieval systems. From entertainment to security, and from data storage to medicine, holography is poised to revolutionize numerous industries in the years to come. The possibilities are endless, and the technology is advancing at a rapid pace. Holography is not just a futuristic concept, it is a technology that is here and now, ready to transform the way we live, work, and interact with the world around us. The future of holography is bright, and its impact will be felt across multiple sectors, making our lives more connected and immersive than ever before. The applications of holographic technology extend far beyond our wildest imaginations, touching upon fields as diverse as medicine, education, and entertainment. This revolutionary technology is not just a figment of science fiction anymore, it is becoming an integral part of our daily lives, reshaping how we interact with the world around us. Imagine surgeons planning intricate procedures by studying three-dimensional holographic models of organs, rotating and dissecting them virtually without ever making a single incision. This allows for unprecedented precision and planning, reducing the risks associated with complex surgeries. Surgeons can practice and perfect their techniques on these virtual models, ensuring better outcomes for patients. This is already becoming a reality in operating rooms around the world. Hospitals are beginning to integrate holographic displays and tools into their surgical suites, providing doctors with real-time, interactive visualizations that enhance their ability to diagnose and treat patients. In classrooms, students could explore the skeletal structure of a dinosaur, dissect a virtual frog, or travel through the human circulatory system, all in stunning three-dimensional detail. This hands-on approach to learning makes complex subjects more accessible and engaging, fostering a deeper understanding and retention of information. Holographic technology has the power to transform education from a passive experience into an immersive adventure. By bringing abstract concepts to life, it encourages curiosity and creativity, allowing students to interact with their lessons in ways that were previously unimaginable. And let's not forget the entertainment industry. Holograms are set to revolutionize how we experience music, movies, and live performances. Imagine attending a concert where a holographic representation of your favorite artist performs right before your eyes, complete with stunning visual effects that make the experience feel incredibly real. These performances can be held anywhere, breaking the barriers of geography and allowing fans from all over the world to enjoy the same show simultaneously. Or watching a sporting event where holographic replays give you a 360-degree view of the action. This technology can provide fans with perspectives that were previously impossible, enhancing the viewing experience and bringing them closer to the game than ever before. The possibilities for immersive entertainment are limitless. From interactive movies where the audience can influence the storyline to virtual theme parks that offer thrilling adventures without leaving your home, holographic technology is set to redefine what it means to be entertained. These are just a few examples of how holographic technology is already making its mark. Its applications are as varied as they are exciting, and we are only beginning to scratch the surface of what is possible. As the technology matures, we can expect even more innovative and transformative applications to emerge. The future of holographic technology is bright, and its potential to change our world is truly limitless. While the future of holography is undoubtedly bright, several technical challenges still need to be overcome before it becomes as commonplace as, say, your smartphone. The journey to making holography a part of our everyday lives is filled with numerous obstacles that researchers and engineers are diligently working to address. One of the biggest challenges is resolution. The clarity and detail of a holographic image are paramount to its effectiveness and realism. To create truly realistic and detailed holograms, we need displays capable of projecting images with incredibly high resolution. This means that every tiny detail must be rendered with precision, which is no small feat. Think about the difference between watching a movie in standard definition and watching it in ultra-high definition. The leap in quality is immense, and the same principle applies to holography. The higher the resolution, the sharper and more lifelike the image. This level of detail is crucial for applications ranging from entertainment to medical imaging. Another challenge is computational power. The amount of data that needs to be processed to create a high-quality hologram is staggering. Generating and projecting holograms requires a tremendous amount of processing power. Current technology is pushing the limits of what our computers can handle. We need faster and more efficient algorithms to handle the complex calculations involved in real-time holographic projection. This involves not just hardware advancements but also significant software innovations. And then there's the issue of cost. The financial barrier to developing and manufacturing holographic displays is currently very high. Developing and manufacturing holographic displays is currently a very expensive endeavor. The materials and technology required are not yet cost-effective for mass production. For holography to become accessible to the masses, we need more cost-effective manufacturing techniques. This means finding ways to reduce the cost of materials and streamline the production process. These are just a few of the hurdles that researchers and engineers are working tirelessly to overcome. The path to widespread holographic technology is challenging, but the potential rewards make it a journey worth pursuing. With continued innovation and dedication, the dream of integrating holography into our daily lives is becoming more achievable